now. Good afternoon. Hi, everyone. Welcome aboard. This session, we are discussing computer fundamentals. I know this is very, very basic stuff. You definitely, know some items or some components from the content, but also there are many new items or new content we will discuss. So this will be beneficial. I hope so, and informative. Please feel free to interrupt me at any time, ask me questions. I'll try to answer your questions. In case you have, you can unmute your mic and ask me, or you can put it in the chat so you don't interrupt the recording or whatsoever. So up to you. I'll share my email also with you. So here we go with my email. So this is my email, sam.elgawadi@tfqld.com.au. In case you have some questions, feel free to email me. The session today, we are discussing the following points. There are other points in the ICT unit or the part related to ICT. There are other points related to networking and connectivity over network. If we have time, I don't think we will have time to discuss network components and networking in general. So we might have another session for discussing the points related to networking. The agenda for this session is displayed in this slide. It's about computer systems, internal components, random access memory, servers, switches, routers, operating systems, hardware, and software. So we are using computers every day. We have computers with us everywhere. And I mean the smartphones, of course, it's a computer. We have computers also in our cars, washing machines, dishwashers, and other components. So computers around us everywhere. We've been using computers for many, many years. So we know the computers from outside. So it's a good idea and chance to discuss the internal components. So here in this slide, it's a blank one about the computer design. So we will fill the blanks. So here we will have like theoretical design of the computer so we can understand how the computer works. So here we have a kind of input devices. So we have some input devices. You can think of some examples for input devices. If you want to share something, what do you think input devices we have for the computers? Some examples.
A USB?
Yeah, USB. USB.
Keyboard?
Yes, keyboard.
Mouse.
Mouse, yes.
Will monitor be one?
Monitor, if it's a touch screen, it could be input and output, similar to the USB. USB also is input and output. But let's delete the USB from here and we will put it in a different category just to be more accurate. We can think of scanner. Yes. What else?
Printer?
Printer will be in the output. So, so let's copy this one. So we have input devices, then on the other hand, we'll have output devices. And you mentioned monitor, you mentioned printer. Okay, what else? What about speakers? Yes, It's output
Like
device.
little speakers.
Yeah,
Okay.
little speakers, big speakers, headsets.
Hmm.
And in input, we can think of mic, the microphone, the mic you're talking in now. So it's an input device.
As an headset earphones.
So the headset
Hmm.
consists of two parts, mic and headphones. So speakers or headphones will be output, because we listen to some output coming from the computer, whether it's music, someone talking like what I'm talking now, and we have also the printer for printing different components. Good. So we have input devices on this hand, and on the other hand, we have output devices. So the input devices will input some data and information. To be more accurate, there is a difference between data and information. So here, let's say we have this color. I'm just, that a good color, maybe light green, a little bit light like that. Yes, let's change the color for this one so we can differentiate. Yeah, I love drawing, but I'm not good at drawing. So here we can think of another component inside the computer, this component, and I need to draw an arrow, and this arrow is one direction, like that. So okay, so we have the data will go into a component inside the computer, and this component is temporary. So temporary storage. And this temporary storage, we call it, we give it a name. Do you have any idea what this name could be?
Hard drive.
A
No?
little, yeah, closer, something else. It's temporary storage. The hard drive is permanent storage. So this one, we call it RAM.
RAM.
Yes. When you buy a computer, it will tell you this computer is 8 gig of RAM, 8 gigabyte of RAM, which is random access memory. So random access memory, this is the full name of the RAM, which is a memory, temporary memory, and temporary storage for interim data and information. Again, information is a processed data. So data is the raw components or raw, we can call it raw material. Then we have the processed one, which is the information. Good. From the RAM, we can just copy this arrow, and we will have the output goes to the output devices. So we said the RAM is a temporary storage. That's why if you have a bigger RAM, you will have better performance in your computer. If you have 8 gig, it's better than 4 gig. If you have 16 gigabyte of RAM, will be better, much better than 8 gig, and so forth. We can have, my current computer is 16 gigabyte of data, sorry, of RAM. It's 16 gigabyte of RAM storage. Okay, so the RAM will hold the data temporarily. And as you mentioned, we need a kind of permanent storage. So let's insert permanent storage here and give it a different color. And this permanent storage, it's HDD or SSD, which is hard disk drive or solid state drive. In old days, we used to use hard disk drives. Nowadays, we are using SSD, which is solid state drive. I'll show you the differences in a moment. So, as you mentioned, we needed permanent storage. Why we needed a permanent storage? Because we, in the computers, when they designed the computers in the beginning, we used to have the temporary storage, and once you switch off your computer or restart your computer, everything will be lost. So we need permanent storage, and this permanent storage is the hard drive. When you switch off your computer at home or work, next day you switch on, so everything is stored there. Where is the Windows or the Mac is stored? Where is the data stored? It's on the hard drive. So here with the hard drive, we have two directions because we read and write from the hard drives. Does that make sense? Yeah. So the RAM, well, if we need to save, it will be saved to the hard drive. Next day in the morning, you switch on your computer and you start reading the files. You open Word file, you open Excel, you open your email. It will come from the hard drive and the network. We will discuss the network later. Good, so two directions here. Okay, now this is the, when you look like that, okay, who controls that? We need a controller. We need something that telling the devices, the input devices, we are typing in English or in German. We need something telling the temporary RAM, keep the data or save the data to hard drive, something telling the hard drive to read or store or delete or update, something telling the monitor to display. So we need a kind of a brain. So this brain here, this is the brain of the computer, and what do you think should be the name of this one? What do you think? Computer brain is the processor. So we have the processor. The processor controls everything. So the processor will read some data from RAM and will write some data to the RAM. The processor will control everything. Processor is a hardware component. The RAM is a hardware component. Hardware means tangible. Hardware means tangible component, tangible item. So we have the RAM. Random access memory is a tangible component. We have input devices like keyboard, it's tangible, mouse, scanner, microphone, output devices. So we are discussing the tangible items here. So the processor is the brain of the computer. Good.
Is that the monitor?
No, the monitor is the display here on the right hand.
Oh.
Yeah, display monitor. Okay.
Okay. Yep. I guess.
Yes.
Yep.
Yeah. So processor, it's called processor, and it's made from silicon. That's why they call the area in the United States Silicon Valley, and it's made of silicon, and the silicon made from sand, pure sand, of course. So it's of course it's complicated design and everything. I'll show you some photos in a moment. So these are the basic components of the computer system, and in between these devices, we have some other components. So, for example, let me insert another shape here. let's go with this one. So the data on the RAM, it's digital. The computer will deal with data as digital data. Digital means zeros and ones. So, you know, your light switch, it has I and O, or 1 and 0. In fact, it's 0 and 1. So when you switch on, it's 1, which means there is electricity. When you switch off, it's 0, there is no electricity. So computers, they understand only digits, but we have also some analog, like our voice. Our voice is analog. It travels into waves. So I'm talking now. When I'm talking, this is a wave, goes from my mouth to the microphone. The microphone will take these waves, the analog waves, and convert that to digital ones inside the computer, so the computer can understand that. Then the computer will process that and deal with my voice, transfer the voice over the network to your location. Then the computer at your end will convert the digital to analog again and put the output to your headphones so you can hear the analog. You cannot hear the digital, you hear the analog. What also analog waves we have, like radio, some radios or old radios, it's waves, old phones using waves, TV transmission or broadcast, it's using waves. So we will have some components inside the computer here that will convert the digital to analog and analog to digital, and we call them adapters. So we have, for example, let me make it a little bit bigger here so we can add more examples here. Let's take this one a little bit. I told you I'm not that good with drawing, right? I was not lying. So, so here we have some adapters, and examples for adapters. We have display adapter. We have, so your network, sorry, your monitor connected to the computer, and it's connected to a display adapter. So it can display videos, movies. We have also sound card, which is adapter. We have network interface card, which is also network adapter, and other examples. So these components will be a kind of here in the middle. So it will help in conversion between digital to analog, analog to digital. Okay, if that makes sense, any question here?
No, I've only. I guess my questions will be when we go back to talking about the screens and that.
Yes, sure,
Yep,
no problem at all.
that.
So this is the basic design of the computers, and just I'll highlight something in as simple as possible. When you in your computer, and when you type, for example, door, the word door, D-O-O-R, so you start typing on your keyboard. So we are on this area now on the left, you are using your keyboard and you start typing. So the computer will understand that by converting the letter D into a number. This number, it's standard number across the whole world. So if you are hitting D in Australia, it's same thing if you are hitting the D in your keyboard in United States, same value. So the computer will convert the letter D into a number, let's say, for example, 50. So this number will be converted afterwards to digits, zeros and ones, electricity. And so it will be converted into digits, then it can travel inside the computer components. Then these adapters will convert back, and then you can see on your screen the letter D, for example, here. Starting the word device starting with D. So it's a journey, but because of the speed of the computer, we hardly notice the speed. it's very, very fast. So they call this table ASCII code. It's a standard coding system. All computer manufacturers since 8 years or 70 years, they agreed on using one code. So all computers across the world, they can talk to each other. If I'm writing in a different language, it will be also converted to different numbers. And this way the computer can understand different languages. If I'm writing in Arabic or German or English or any language, it will be converted to some coding, and this code is a standard, whether this computer is manufactured in China or Japan or United States or wherever. So here, these are the different components as we discussed. So I'll show you now some examples of these components. And before we go further, I just need to highlight this area. So we call this one motherboard. So it should be motherboard of the computer. So the whole area, it's a motherboard, and the processor, in some books, they call it CPU, which is central processing unit. Okay, central processing unit, which is CPU. So we have CPU for the processor or central processing unit. We have the RAM, random access memory. For short, they call it memory, computer memory. We have the hard drive, which is the permanent storage, or SSD drive, same function, but better technology, faster technology. We have different adapters, and these adapters, they work like components. For example, display adapter, sound card, it's an adapter, network interface card, it's an adapter also. So they convert digital to analog and vice versa. Good. Examples. So here, this is how the RAM looks like. So this is the random access memory. The RAM you are seeing in front of you, this is the one for the PC, the desktop. For the laptop, we have shorter one, smaller one, but this is how the RAM looks like in most cases. Of course, there are different colors. It could be green, it could be brown, it could be red, but it doesn't matter. This is how the RAM looks like inside the computer. And as we said, the RAM is this part. So here, it's a temporary storage. So it will be stored here. The bigger, the better. Just a note here regarding the RAM. Your motherboard, when it's designed to have a maximum capacity of the RAM. So let's say my motherboard here for this computer, the maximum is 30 gigabyte of RAM. So it can support up to 32 gigabyte of RAM. I can't put more than that. So this is the maximum. So for your computer, if you need to upgrade the RAM, you need to check on that. You need to check on the maximum capacity you can have on your motherboard. And as we said multiple times, the bigger, the better. So
does it go by branding as well?
There are different brands for the RAM,
okay. Yep.
like Gigabyte or I just don't remember the other brands, but there are different brands. We
Yep.
can have a look on we can search that online and we can see different brands. Kingston, also one of the famous brands, Kingston, but different brands, different prices. And it is not that expensive nowadays. In older days, it used to be very, very expensive. While we are discussing the RAM, let me highlight something. So good that you asked this question. It reminded me of maybe something we need to think of, which is byte, then megabyte. Sorry, before the megabyte, even we have kilobyte, megabyte, then we have gigabyte, then we have terabyte, and we have other ones. Let's see, exa. Okay, so you remember I said one letter, for example, letter A. This letter A or B or C or symbol like plus sign or minus, when you input this one from the keyboard, we said it will be stored temporarily in the RAM and it will be converted into a number. When we store the letter or the digit or the symbol, it will be stored in 1 byte. Sorry. So every byte is 1 letter. So this will be storage for a letter, digit, or symbol. Okay. So 1 byte is the storage name for a letter, digit, or symbol. If we have, so in the beginning, we started with 1 byte. We need to store more. So we have 1000, which is kilobyte. To be accurate, it's 1024 bytes. So kilobyte is 1024 bytes. So in a kilobyte, I can store up to 1024 letters or letters and numbers and digits. Then we have megabyte, which is million. So kilo is 1,000, like kilogram, it's 1,000 grams, kilometer, 1,000 meters. So then we have megabyte, which is 1024 kilobyte. Then we have gigabyte, and this is 1024 megabyte. So giga is like billion. Then we have terabyte, and the terabyte is 1024 gigabyte. There are other storage also names like exa, beta, and other names. So again, the megabyte will be 1000 kilobyte and 1024, and the kilobyte 1024 bytes. So your memory now, the memory you have in your computer at the moment, most probably it will be 4 gigabyte or 8 gigabyte. My computer is 16 gigabyte RAM, so this is the memory. Your hard drive, maybe it's 256 gigabyte or 512 gigabyte, or more. My hard drive is 2 terabyte. Maybe yours is 2 tera, 3 tera, I'm not sure, but these are, usually we use that for terabytes for hard drives. Nowadays, hard drives are SSDs, so the permanent storage will be like half tera, which is 512 gigabyte, or 1 tera or 2 tera, and so forth. So, does that make sense?
Yep.
Yeah. Okay.
Yep.
Yes.
It's clear now. Yeah.
Okay, that's good. So in most cases, when we go to a computer shop and we need to buy a computer or laptop, in most cases you will find the RAM goes around these numbers. So it will tell you 4 gigabyte of RAM, 8 gigabyte of RAM, 16 gigabyte of RAM. This is the most cases, the most common size of the RAM. And for hard drives, starting from 2, sometimes it's telling you 128 SSD, 128 gigabyte, 256 gigabyte, 512 gigabyte. Also, it can go to 1 tera, 2 tera, 3 tera, something like that nowadays. So this is the different sizes for different storage components. So the RAM nowadays, as we mentioned multiple times, 4 gig, 8 gigs, 16 gigs. Okay. Then we discussed that. What about the processor? How the processor looks like? It looks like mostly this one on the right hand. So you see it has the word or the abbreviation CPU, which is Central Processing Unit. Again, this is the computer brain, and the faster the better. Of course, the faster, the more expensive. And this is this photo from the bottom. So this is the bottom of the processor, and this is the top of the processor. This one, the black one here, this black processor, it's an old version of processors, like 20 years ago or something like that. So it looks like that, but nowadays the processors, by the way, in the beginning, processors were looking like that, then they changed to that, then they came back, they go back to this design. So the design is like that from the top, and this is the bottom. I can make it a little bit bigger so you can see like golden bins. And smaller again. So this is how the processor looks like. Again, if we go back to the design, the processor is at the top here. So this is the brain of the computer. Then we have the body and different arms and legs, different inside components. Good. So what about adapters? How the adapters looks like? So we have seen the memory now, we have seen the processor. What about adapters? The adapters looks like this one. So this is a display adapter. It's pretty old, not one of the new ones. We have a pretty old one. Of course, if we Google display adapters, we can see different types. I can show you also if you are using PowerPoint, so and you need to insert a photo from online, so you can go to insert online picture. Then here you can also conduct a kind of search. Yeah, it goes online and start searching. It's a little bit slow now because of Zoom is taking the bandwidth. So that's why it's a little bit slow. Anyway, I can conduct the search in the browser. I'll show you that later. So now the adapter looks like that. This is the display adapter. Display adapter. Let's focus what is the functionality of the display adapter and how it looks like. Let me make it a little bit bigger. So the main functionality of the display adapter is converting the digital data and information from the RAM and take this data and display it, or the information to be more accurate, and display it on the monitor, display it on the screen in front of you. We go back to the design. So display adapter here on the right hand in this black box here, and this will take the data / information from the RAM and output that data and information to the monitor, so you can watch movies, TV series, whatever. Okay. So display adapter components, we have memory on the card. So we have memory here. This is, as I said, it's an old design one, but still these are the memory, temporary memory. It's a kind of RAM. That's why when you need to buy a computer for gaming, for example, you play games a lot, or for graphic design, video editing, you will need a very strong display adapter with minimum of 2 gigabyte of RAM. So you can play games smoothly, you can edit the videos or process the videos smoothly. So if you are dealing with videos / games, you need a very strong display adapter. Very strong display adapter means bigger RAM size, better processor. There is a processor here under this fan. So there is another processor. We call it video processor. We call it graphic processor. Different names, commercial names. After all, it's a different processor. So other than the main processor we have seen, so the main processor there, we added another one. In some cases, we call it GPU, graphic processing unit. So this is the scientific name, the computer from the computer science point of view. So this processor will help in processing the amount of data / information needed to play the game or edit that video or edit that movie and create some output here or deal with some output. So the display adapter will consist of processor, different RAMs, and you see there is a fan. This fan, the functionality of the fan to keep the processor cold so it can function well. Then the connectivity itself here, the way of the connection here, it requires, it depends on, again, what you are doing with your computer. If you are playing lots of games, advanced games, latest games, or editing videos, so you need a better connectivity. This connectivity will help in the transfer rate for the data between the motherboard and the monitor. So it will take the data from the RAM, which is connected to the motherboard. I'll show you that in a minute, and display that on the monitor. So these are the three main components: processor, RAM, then connectivity to the motherboard. We have a fourth component, which is how we will connect to the monitor. So you are connecting your monitor to the back of your computer. It will be connected to the display adapter, and it will be connected through DisplayPort, VGA connection, or HDMI. HDMI is the latest. We've been using it a few years now, of course, but in many cases, you will have VGA or HDMI connectivity. HDMI for better resolution. Of course, better resolution means more data needed to be processed. Better connectivity here, better processor there, bigger RAM. So, and more expensive. Display adapters comes in different shapes. Some of them will be built in on the motherboard. Some of them will be, looks like the one you see in front of you, which is an adapter. So you can connect that to the motherboard. Any questions here?
So why have we, the world moved away from the AVs, the yellow and red and yeah, yellow and red?
Yellow
Is
and
it
red,
just
what?
the AV cords? Were they? Oh, sorry.
Yeah, because of the amount of data we needed to transfer. So we have 4K now resolution, 8K resolution. So the amount of data required to travel in the wire, it's much, much bigger. So we need a better road for the traffic. We need a bigger road with better quality. So we changed the cables itself. We changed the cables to HDMI cables, which can process or transfer this amount of data, and it will be wider and faster. Okay, makes sense?
Yep,
Yeah.
okay.
Okay. So this is the display adapter here. This is the one. Then we have also network interface card. It's an adapter, but this one will take, it's an input-output device, and it will take the data and transfer that to the network. Of course, we are connected to a network now. That's why I can hear you, you can hear me, see me. We are all connected to a network. I have network in my house, you have network at your house, and work, and all these networks connected together through internet. So internet is the network of the networks, and to be able to connect your computer to a network, you need a network adapter. The one we have in front of us is the wired one. Most desktops, they have wired network card, like the one we see in front of us, but also most laptops have wireless network card, network interface card. It works almost the same way. It will transfer the data from computers to different networks, to internet, and vice versa. So it's input and the output device. So here, the network interface card, the one we see in front of us, it's the big one. We can connect it to desktop. But your phone, your smartphone, includes a wireless network interface card. That's why your smartphone is connected to internet, connected to Wi-Fi at your home or work or McDonald's or something, so which is dangerous. But your phone also includes a network interface card. Your tablet also includes network interface card, but wireless one. So you can connect your tablet, laptop, PC, phone to Wi-Fi. Good. We will discuss more about networking in the coming session, but for the time being, we now understand the network interface card. Again, it is similar to other cards. It can, when the technology advances, it can transfer more data. It can transfer faster data, so bigger in size and faster in speed by improving the connectivity, improving the process happening within the card itself. We can have different connectors here. We can have fiber optics connector, which is very fast. It's almost light, so the speed of light. We transfer the data like the speed of light. Think about aeroplanes or rockets traveling to Mars or something. So we need very fast connectivity. So or computers process big data in wars, for example, or missiles or whatsoever. So it depends on the amount of data you need to transfer, and the faster, the better. And of course, it will be more expensive. So technology advances here, and we transfer different data rates. Okay, just I'll go back here to add something here. 1 byte equals 8 bits. So you remember the smallest component was byte. So 1 byte equals 8 bits. So here we are talking about storage. If we are discussing speed, so let's say this is, go here, this is and this one, it's another title. So in the speed, let me a little bit bigger here. In the speed, we will have, let's say, 100 megabit per second. So this is the speed of transfer. Again, this is megabit. If you need to calculate that into, so divide by 8, so it will give you in bytes. Okay, let me explain this one a little bit more. We have storage, and we agreed that the storage, when I hit A, for example, it will be stored in 1 byte. Good. Is there a smaller than 1 byte in the storage? Yes. This storage consists of 8 bits. So this is the smallest unit we can deal with in the computer science. Good. Do you need to remember that? You don't need to remember that. It's not, you just need to understand that so you can have a better understanding of the computer work. Okay, so 8 bits. So 1 byte will be consisting of 8 bits. When we talk about speed, so we will use the B small, which stands for bits. So the B capital you see B capital stands for byte, but the B small stands for bits. So the speed of the network card, for example, it's 100 megabits per second. Okay. If you need to know how much is that in bytes, you divide by 8. Okay. Then if you need to know how much is that in, you multiply by kilobyte or divide by kilobyte. It depends on the calculation. Good. So the speed here of the network card, we measure this speed by megabit per second. Good. What about hard drives? Hard drives, we have different hard drives. This is the old one, on the right-hand top corner. This is the old hard drive. You see it's mechanical here. We have like metal cylinders here, and we used to storage the data here using magnets, so magnetic fields. Then we improved a little bit to SATA, still a little bit technology faster. Then we went into SSD, solid state hard drives. So it looks like that. So these are the SSDs. We are using the SSDs nowadays in our laptops and smart devices like smartphone, in your tablet, in your so tablets, phones, and laptops. So we use SSDs, and also desktops, we use SSDs nowadays. SSD is much better. If you drop the SSD, it will work, no problem at all. It's a digital one. It is not a mechanical one. In old days, this is the mechanical one. If I dropped it, I lost the data. Most probably it will be corrupted. I can't use it again, most probably. But nowadays, we have the SSD. The SSD, it's similar to the USB you have. USB, if you forgot your USB in your pants or shorts and you wash that one in the washing machine, the USB will keep working afterwards. So you still have the data there because it's a digital one. Okay, so more reliable, bigger size, faster than the old ones. Okay, any questions? That makes sense now? Yeah?
Yep.
Okay. Do you need a break, like 5 minutes break to grab something for stretch or something?
Yeah, could I get a coffee?
Yes, okay. 5 minutes break, then we will continue. I will pause the recording.
Awesome, thank you.
For 5 minutes. No problem. 5 minutes break. Okay, so before the break, we discussed different types of hard drives. We said this is the one on the right hand top corner is the old one. Then we got with we came with SATA, then SSDs nowadays. Then how the motherboard looks like. I have two motherboards here, not very new ones, but again, you can just Google motherboards and you can see different photos, different pictures for the motherboards. So let me just the one here on the left hand under the fan. This is the processor. Then we have some connectors or slots. These slots for connecting RAMs, the memory. We have battery here. This is the blue part here. It's like battery. This is keeping date and time and configuration. We have some other slots for connecting adapters. We have the different connectors at the back of the motherboard, and this is at the back of your computer, like VGA or display adapter, sound card, different network connectivity, and other USB ports. On the right hand of another motherboard, so we have here the yellow and black on the right hand. These are the memory slots, so we insert the memory there. We have the processor there, this processor without the fan, so it's connected. They remove the fan, just we can see the processor. This blue part is a heat sink, and we can know below this one is the display adapter built in on the motherboard display adapter, and it needs a heat sink to keep it cold as much as possible. Computers needs to be in a cold weather, 16 degrees when we have data centers, but if it goes like 38, 40, or 35, this is too bad for the computer. So if inside your house or work, it's that heat, we need a kind of cooling system, air conditioned. These slots here for different components, different adapters, display adapters, or sound cards, network interface cards, and other ones. Here, these are the connectors for keyboard, mouse, printers, and other types of connectors, network cards, and so forth. So this is how the motherboard looks like. Again, if we go back to the design, you remember the design here. So you notice the motherboard includes different components. Any questions here with the motherboard? Any question? Anything you need to clarify or ask about? All good?
Just is the motherboard the same as in motherboard on a TV, be on a TV?
Same name, but different components.
Okay, yep.
Yeah. There is a motherboard in your car. There is a motherboard in your washing machine, dishwasher, TV, yes, as you mentioned, in your tablet, in your phone, laptops, desktops, motherboards, but different components, of course, based on functionality. Okay, your PlayStation, your Xbox also includes motherboard with processors, RAMs, and hard drives. Okay, now we will discuss some more items here. So at your home, you have a device, and this device connecting you to internet. So what is the name of the device you have at home? Not the brand, the name. What do you call it?
Modem.
You call it modem, okay. Any other names? Router? You call it router?
Yeah.
Do you call it switch?
Sensor? No?
No.
No, sensor.
It will be switch, router, in some cases.
Monitor?
No. Modem. Monitor is the display screen. So,
no, you know, like in old computers, blah blah. The old computers where you've got the screen monitor, and then there's that big black box next to it. Is that a monitor as well? Is that
no, the black box is the case, computer case.
Oh, right.
Yes. Yeah.
Okay. Yeah.
So monitor is the screen, display screen. Okay. So the device you have at home, the commercial name, sometimes we call it router, sometimes we call it switch, sometimes we call it modem. It depends. The device I have at my home at the moment, it's a switch and router at the same time. It's wired and wireless at the same time. It is not a modem anymore. In old days, we used to use modems when we needed to connect telephone cables to our computers. So I needed to connect telephone cable to the computer so I can connect it to internet. So in old days, and this is still in some areas of Australia, they are using ADSL. So they are using telephone cables. If you are using the new technology implemented recently in Australia in many areas like NBN, this is the fiber optics. So you don't need a modem. The modem, its main functionality is connecting, in simple words, connecting, and simple examples also, connecting the telephone cable and the telephone network to your computer so you can reach internet. Nowadays, we are using fiber optics and we don't use modems anymore. We use different units or
what's
connecting
fiber
devices.
optics?
Fiber optics, it's a cable made from glass.
Oh, okay. Yep.
Yeah, so it's very, very reliable and very fast. So the data transfer there at the speed of light. So can you imagine the speed is really good. So you can watch movies online without the need for download the movie first, then watch it. So you can just watch live streaming. So the device you have at home nowadays, it's called, the commercial name, it's a router, but the from a computer science perspective, the proper name, it's a switch and router at the same time. And in most cases, it will look like the one we have in front of us, or different types, different looks, different brands. But the main functionality of this device at home is connecting your home network together. So you can have a small network at home. So your computers are connected together. You can share one printer. You can print from your phone to your printer if you want to. You can do many things. And also all devices at your house connected to internet through the router. So what is the difference between the switch and router? Very, very important difference. We need a switch to build a network, internal network. So for internal network, we need a switch. So at your home or at your workplace, you definitely have a switch. Why I'm saying definitely? Because you are connected to internet and you are connected to other devices. I can communicate with you now. So definitely you have a switch or 100 switches. Definitely also you have a router. Router connecting the network to a different network. So the router is a device between two different networks. So if I need to connect my home network to internet, I will use a router. Do we need the switch and router? Yes, of course, because the switch will build the local network and the router will connect me with the external network, like internet or other networks. Good. What if I need to connect my network in the building A to a network in building B? If they are different in configuration, we will need a router between them, in addition to switches, of course. If they are the same configuration, we don't need router. We will use switch. So the switch will create network, the router will connect different networks. They are different in configuration, in settings, in functionality, different details. We don't need to go into depth at the moment. So again, the device you have at home, it's a home device, or they call it SOHO, small office, home office. That's why we are using one device, includes router and switch and maybe other devices also included there. But in reality, and I mean enterprise size, we have switches and routers. They are separate devices with separate functionality. Does that make sense?
Yep.
Yeah, any questions? Any questions?
And this is, sorry, this is all connected by NBN, yeah? So this is how
If
you
you have,
get your,
yes, if you have NBN, so all connected through NBN. Then our NBN in Australia, or our internet across Australia, it's connected, for example, to Singapore through cable there is a cable in the ocean. So they are using submarines to have these cables between continents. So there are cables in the ocean, under the sea, by divers and submarines. The cables there connecting Australia to Singapore, then from Singapore maybe to China or United States or whatsoever. So all continents, they are connected together through cables inside the ocean.
Wow, thank you. I did not. Wow,
We
good to
use
know.
also
Yep.
we use also satellites. So we have connections across the cables, and we have wireless connections through satellite. So if you are in the aeroplane, you are flying from maybe Sydney to Melbourne, or from Townsville to Sydney, maybe they have Wi-Fi in the plane. It's connected through wireless or satellite somehow. So we have satellite connections, and we have like sea cables. Good. What else? Yeah, no problem. What else we need to think of and see? Servers. So, for example, you are sending every day, you are sending emails, receiving emails from your Gmail, from your Hotmail, from your work email. These emails will be stored, managed, created, sent, deleted, updated, backed up using servers, email server. The email server is a software that is stored on a hardware. So this is the server looks like. So in front of us, we have 3 servers. Server, in simple words, it's a strong computer. It looks different, but it is a computer after all. So the computer you have in your phone, it's different than the computer you have in your workplace, but after all, it's a computer. So what we see in front of us here, it's 3 examples of 3 servers. Server is a strong computer. We need strong computer in our organizations, enterprise size. Why? Because we need to have email server. We need to have username and password authentication for different employees. We need to have some file sharing. You share files through the server. You have some database. You have some applications like payroll application or financial applications. You have email. You have antivirus, centralized antivirus. You have different components of the network. So we use what's called servers to control the network. And this is how the server looks like. In the session related to networks, we will discuss more about that. Then the components we were discussing till now, these are the hardware components, tangible components. We can see them. So these are the different devices and different peripherals. So starting from memory, hard drives, other adapters, and so forth. So these are all hardware components. You can touch them. It's like the body of the computer. But we need also to have the soul of the computer. So the soul of the computer is the software. So we have hardware components connected together through wires or wireless, but we need a kind of software. This software is the soul of the computer, telling the processor what the processor needs to do. We give the processor instructions, and the processor will follow our instructions. So you open Word, or you open your email in the morning, and this is a software. It's an application. Once you open this one, you are calling this software to run on your phone, on your laptop, and on your tablet. It's a software. nowadays we call it app, which is application. So you have a mobile app, you have application on your desktop. So in the morning, you switch on your computer or your phone. Then there is operating system in the beginning. For example, the computer in front of you could be Windows. So you have Windows operating system. It's a software stored on the hard drive. Maybe you have Mac. So it's iOS, Mac iOS, or Mac operating system. Good. You switch on your phone, and your phone may be Android. So the Android is the operating system for the phone, or you have iPhone. So again, it's iOS for iPhone from Apple. So nowadays we are using either Android or Apple iPhone. So this is the operating system. Then after the operating system, we will have some apps, like you switch on your computer, Windows starts first, or Mac, then you will click on or touch Outlook to open the email, or Gmail to check your Gmail, or Excel, PowerPoint, Zoom, anything. So these are applications comes after the operating system. So the generic name for applications is software. Good. Let me just go to the slide about software. So software is a generic word. We don't say softwares at all. This is wrong, totally wrong. It's software for plural also. So starting with operating system. So operating system, for example, we have Windows, we have Linux, we have iOS, and other operating systems. Then we have Office components, or Microsoft Office, if we are talking like Word, Excel, PowerPoint, Outlook, other things also. So we can have other things. We have different utilities. So like Acrobat Reader for PDF, you open the PDF files. You have, for example, WinZip or WinRAR for zipping or archive some files. You have scanner application, you have printing application, so other things. Here, antivirus like McAfee, Norton, AVG, many antiviruses. Symantec, AVG, okay, yes, this is the correct one. Browsers, internet browser, give me some examples. Browsers.
I was trying to think. There's Explorer.
Yes,
Chrome.
so Google Chrome, Internet Explorer, or Edge.
Edge. Is that Edge? Is Edge Microsoft? No.
Yes.
Microsoft.
Mozilla. Yep. Yes.
Is Firefox?
Firefox, yeah. This is the Mozilla thing. We have Opera. There is something called Tor. So these are all applications, software. What else? Can you give me other examples of applications you are using?
So is application like
Software.
software?
Yeah. Zoom.
Ah, okay. Zoom, Microsoft
Teams?
Teams.
Yes.
Yep, Teams.
Okay.
telehealth. Oh no, that's different. Telehealth.
Line meetings. Category. Okay.
Skype.
Yes. Good. Skype. Yeah. Any other categories? Games. Do you play games? Any games at all?
Yep. Yep.
Okay. Do you play FIFA? What else?
Basketball.
Okay. Any
And
other games?
there's an online one.
Anything. PUBG.
PUBG, I haven't done ages. Mario.
Super Mario. So, okay. So these are all applications. You use also applications like work application for submitting your annual leave or salary. You check for your salary and whatsoever. Bank transactions. It will be through your bank app on your phone from ANZ, Commonwealth, whatsoever, and other things. So there are many, many applications. And yeah, here examples for Windows, Linux operating systems. So operating systems, we will have desktop, we will have tablet operating systems, we will have network operating systems. Other devices like your washing machine, there is operating system there. Your phone, there are operating systems there. So we have Windows Server client, we have Linux Server client, we have Mac OS, we have iOS, we have Android, as we mentioned before. So these are the different operating systems. Okay, that makes sense? Yeah.
So for the old Nokia phones, what was that? Were they?
I don't remember the name of the operating system. It's Nokia operating system, but I don't remember the name.
Yeah.
It's different operating system.
Yep. Okay.
Okay, makes sense. So again, I'll go back to the design and summarize what we were discussing, starting from the beginning. So we said that these are the tangible components, the hardware components. We have input devices. For example, we have the keyboard, mouse, scanner, microphones, or mics. These devices will input some data into temporary storage, and the temporary storage is called memory or random access memory. Then the memory will take the data, send it to the processor. The processor will process the data, so the data will be converted from raw, unuseful data to useful information, and in exchange with the RAM and the processor, we will have data and information. We will store that in a permanent storage, and we will display that on the monitor in output devices, or we print, or we listen to music or movies, so we can watch the movie, listen to the movie. We will need some adapters in between, like display adapter, sound card, network interface card to connect the computer to network, and everything stored on a motherboard. So these are the tangible components. We needed something tell the processor to follow the instructions, and this is the application. So, or the software. We have the software, and we have different categories for the software, starting from the operating system. We need operating system, Windows, Mac, Android, iOS from Apple, whatever the operating system. Your washing machine includes operating system. Your Xbox, there is operating system there. Your tablet, your phone, your computer, your network, your server will include operating system. We need an operating system as the basic component of the software. Then we add different applications. So we have different applications like PowerPoint, Outlook, Zoom, your bank application, your antivirus, your game, the game you're playing, and so forth. So the computer consists of hardware and software. If some parts of the hardware not working, so we need to maintain that. If it's fixable or maintainable, so we can fix that. Otherwise, we will replace it. When we replace that, we need to make sure it's compatible with the other components for the hardware. For software, we can reset the software. We can uninstall some software, install it again, or operating system, we can erase everything, then reinstall, set up the application, or reinstall everything again, format the hard drive. So the hard drive will be able to delete, everything will be deleted, then we'll format to prepare for the operating system to be installed. Nowadays, installation is very, very easy. Just you download something, you run it, and double click to run it. Make sure you have a licensed and clean applications, and you follow policies from the workplace. At home, also avoid any malicious software by downloading from trustworthy websites like Microsoft or Oracle or Cisco or something. It depends on the website you are downloading from. So these are the main components of the computers we discussed today. I hope it was an informative session and you learned something new today. Your input and discussions also were really beneficial. Even during the break, we had some discussions. So now it's time for you to ask me questions, and feel free to unmute your mic and ask me. I'm still recording that. Maybe you have some beneficial questions that we can use with other participants. Then maybe for a few minutes, I can answer your questions. Then we can stop the recording and you can answer any other questions you don't want them to be recorded. Feel free to do so related to computers or networking. I'm more than happy to do that. So again, I'll go back to the first slide so you can have my email and you can email me also any questions you remember. After this session, you need to ask me something, please email me. I'll be more than happy to reply to your email as soon as possible. Okay.
I just want to ask,
Yes,
sorry.
yes, sure.
Just about the assignment. When do we, when's this due actually?
Have you got the email from Melanie about the due? I think it's mentioned there, but
okay.
Offline I can check that and check the email and get back to you after we stop the recording.
Okay. Yep.
Any other questions related to what I have explained today?
No questions from me.
Yeah,
okay.
no
Have you learned something new today?
Yeah, more of the megabytes and kilobytes, like.
Okay.
And is it the computer design, like how input and output?
Okay.
So is it input and output similar to like negative and positive, but not exact, but just to interpret it that way?
Okay. Okay. Anything else you learned?
Clara, did you learn anything?
Can you hear me?
Yes, Clara. Now.
Oh, sorry.
Yeah.
Well, I think like all of this information is relatively new to me. Like I just basically just thought,
Your
that it
mic muted a little bit, so we lost you. We lost you again, Clara. Okay,
is that better?
yes, now we can hear
Yeah.
you.
Sorry, it's my reception on the my computer.
It's okay.
No, I thought everything was really really interesting. Like I just thought I didn't really think how complex like a computer can be. So this is relatively new information, and yeah, it was very interesting for it to be broken down to how you explained it. So yeah, this is very insightful.
That's great. Thank you. Thank you. I'm really happy that it was informative and we learned something new today. Please, again, feel free to email me if you have some questions. I will stop the recording now. Then if you have other questions, you can ask offline.